Started. Hi, everyone. Welcome to our introduction to Git repositories and to GitHub in general. I hope that by the end of this, you'll have a good working understanding of what GitHub is all about, how to leverage the tools that are within GitHub to allow you to really track your progress through your code and to have a place where you can collaborate on your projects with other people, irrespective of location across the globe. GitHub is really a powerful tool. So I'm going to share my screen. There we go. And you should be looking at a GitHub Git Repository Basics Learn lesson on the Learn curriculum. This is the basis of this study group, is this lesson. We're not going to spend a lot of time in this lesson itself, but we are going to look at a couple blog posts to talk about Git, and then we're going to actually create a Git repository together and play with it a little bit. And throughout the lesson, if you have any questions, either feel free to interrupt me or to put them in the chat box, and I will definitely look at them throughout the session. So let's take a look at a couple articles and walk our way through them. The first one I want to look at is this one from these are both from a website called The Practical Dev, dev.to, which is a great place to do a couple things. It's a great website where you can establish your own blogging presence. It's a really warm and welcoming community of developers from across the skill levels. There's people here who are very seasoned, people who are just beginning on the journey, and they've really cultivated a community that is non-judgmental, that is friendly, that doesn't believe that there's bad questions and is not shutting down anyone. So you can publish your own blog posts here quite easily. And also, if you come here every day, there's just really a whole slew of new blog posts on a multitude of topics regularly. So this blog post is from July of this year, so a few months ago, by one of the bloggers on The Practical Dev, and it's called A Quick Introduction to Git. And this is just a really great rundown of a lot of the features that you can do with GitHub. And again, we're actually going to spend the bulk of our time together actually doing these things in the command line. But it's good to get a little basis of where we're going to start from by looking at some resources. And I love resources, right? So the website, just once again, is dev.to. That's how you get to the website. So first of all, what is Git? So GitHub is a website, but Git, what is Git itself? So Git is a distributed version control system. It's a way to manage the changes within your code. It was created in 2005 by the Linux community. The goals was mainly that it was going to be fast, fully distributed, have strong support for nonlinear branches, and could be used for large projects. So there are essentially three states within your files in a Git repository: modified, staged, and committed. And we can see it actually down here as well. So when a file is changed, it will be marked as modified. So it's there, right? But will not be committed. The only files that will be committed are those which have been staged. So the first step is you modify one of your files within your Git repository, and now that file is marked as modified. But it's not actually been pushed up to your repository in GitHub until you stage it. And then once you stage it, then you can commit it. And then when files are committed, they're safely stored in the repository, and it is under version control. So let's take a look at this for a second. Here's the working directory. Here's your staging area. And here's your repository, right? So check out the project goes this way, right? You're checking out the project, i.e. you are working on a Git repository. So you're starting from the Git repository, which is the central location, the version control location of the project. And then you start here where you're working from, usually from your own local development computer, your own, whether it's a work computer or your own laptop or what have you. You're staging the changes, git add, we'll talk about what that is in a minute, git add, and then now it's in the staging area, and then you're committing it, and usually with git commit is the command, and now it's put back into the repository and you've updated the repository. So the working directory, the staging area, and the repository. The working directory is the place where you work with your files. That's literally your computer, right? The working directory. When you want to store the changes, the first thing you do is to get the files to the staging area, so Git knows what to commit. And now that the files are staged, those files can be committed. So the way that they're stored is they're stored with version controls, with different numbers that iterate, that let you know each time you have made a change, you can track through the changes. So let's take a look at a working example. So let's just take a look at repository on my profile for a minute. Give it a second to load. Okay, so let's take a look at this just as an example. So if we look at, there's 107 commits here, right? And do you see here 59C2144? That is the reference to this commit the last commit I made on this project. And then each one of these commits, there's one here from Mulkey. Each one of these commits has a unique identifier, unique reference number, and that actually allows you to backtrace through your commits, and you can actually you can go back in time if you wanted to. Let's say you made a major mistake, you can actually go back in time and go back to an earlier version of your program with an earlier commit using these reference numbers, and it's really cool to be able to track through. And then these are the commit messages. Good commit messages tell you succinctly and clearly what you did in that commit. So here, like these three are not really good commit messages. You would have to, and full onus on me, you would have to go back and look at like what I was doing there, why I named them. It's probably because I made quick fixes really quickly and didn't think about renaming the messages. But here is refactored API reducer action and render card. So you get a sense of what's happening here. Here, Mulkey did remove console.log refactor conditional. So people who are looking through your code can get a sense of what is happening in each commit. Okay, so here's the 4 steps. So you would pull and merge from the origin master, which is the repository. You would resolve the, let's get to that in a minute. We'll get that as different blog posts. My mistake. So how they get their naming, the conventions for how the commits get identified, that's within this article. It's without the scope of our time together. But if you're interested, you can go to this blog post and you can read exactly how they get named, these identifiers, these reference numbers. So the way that we would initialize a new Git repository is from our command line. We would type git init, and you can figure out that init is short for the word initialize, right? So the way you initialize a new Git repository is by typing initialize, but in shorthand form, git init. Git is your keyword, it's your commands for everything with regards to GitHub. So all of what you want to do on GitHub is prefaced with typing git, and then git, and then init or git whatever. So in this case, you're creating a new Git repository, and that makes a hidden directory within your main directory, a hidden subdirectory called .git, which would hold the history of all your Git actions within that Git repository. It holds the data about your repository, such as config files, all your commits, branches, and tags. We'll skip this for a minute, but again, if you're interested, you go back and read what adding --bear does. It's not really important for our time together. And then let's say I wanted to, so going back to this example, let's say, okay, let's say I'm not the author of this repository. I have nothing to do with it, but I'm really interested in it, and I want to work on it. So I would clone it, right? Well, first I might want to fork it. Forking it makes it a local copy. This here would make a local copy of it on my GitHub account. And then once I would do that, I would then want to clone it. So this is the link to clone it, and I copy to my keyboard. And then if I wanted to clone it, I could type git clone and paste. That's just pasting. And then once I would actually press enter, that would clone that whole repository down to my local computer. Really, as you can imagine, really, really helpful feature there, git clone. And very easy to get the URL for that clone by simply just going to the green button and hitting the copy to clipboard link. Pretty cool, right? So great visualization. The central repository, the origin, git clone to your local repository. Pretty easy. So let's say you've cloned down a repository you're working on. It could be a lab from Learn. It could be an open source project. It could be anything, right? And you've made some awesome changes. You've really done some great work on it. How do you go about adding what you've done, pushing it back up to GitHub. So again, if git init initializes a new GitHub repository, git add adds the changes you've made. Pretty easy. So far, pretty easy. And how would you use git add? Git add either the name of the file of the directory or simply git add dot dot. Git add dot. And dot is short for everything. Add everything I've modified. So let's see here. So if we would go into, let's say this project, and I would look to see, well, nothing is, I haven't changed anything here, but I could do git add dot dot, and it's not going to add anything because there's no modified changes. But let's say just for a second here, I open up the repository and I change a really minor change, and then we would type git status. You see the difference there? Git status here tells us your branch is up to date with origin master. In other words, your branch that you're working on your computer is up to date with the origin branch, which is the repository on GitHub. Nothing to commit, working tree clean. But here I changed just a couple words, right, and saved it, and GitHub or Git was able to automatically know in real time that I made a change. So now look, change is not staged for commit, meaning these are not staged yet. I've made the change, I've modified, but I haven't staged it. What have I modified? Just one file there. And so if I would now type git add, that would add that to what in the staging area, in those three parts, in the staging area. And then if I would type git commit -m, which is short for message, I could put, change comment on in.yml. Something really simple, right? And then the way I would want to push that up to GitHub is git push origin to origin from my master file. Once I'd press enter, after I did the commit message, you would see a little status saying that we've changed something. We're going to do all this in a clean repository file in just a minute or two. Oops, clicked the wrong thing. So that's how you would add it. And then here's the git commit, right? Git status we just saw, right? Because git status allows us to see what changes are to be committed, what changes have not been staged for commit, and what are our untracked files. Git log, it shows you all the commits in the repository, the latest commits at the top. So we would type git log. Look at that, a lot of commits, right? And you can see them. And here's the reference number, here's the message, and here's who did the commit, right? So different people, who did the commit. And since there's so many, let's just press Q. There's a great way to quit out of that and go right back to your command line. Git log --stat. Parameter will only show you which files have changed. Pretty helpful. Now branches, I see a chat box. One second. Where physically is staging? On your computer or on the remote repo? Everything from, it's a great question. Everything from, let's go back up to that thing here. Everything from working directory to staging is happening on your computer. Nothing is changing on the remote repository, on the GitHub repository, until you commit it. Does that make sense? These first two things are happening locally. And then when you push it up to repository, that's when you're actually interacting with the remote repository. So let's go back down here. We were on branches. Branches is a really powerful tool. Another chat. So what's the purpose of it? The purpose of it is for the whole purpose. No worries. I love questions. Questions are great. The purpose, yes, that's exactly what's going on to the development code folder. Exactly, Ryan. The purpose of all of that Git staging is for you in order to track. So every time that it's code version control management. So every time that you push up to the remote repository, Petya, what you're actually doing is you're pushing not only the files you've changed, but you're also pushing the staging history. You're pushing up the commit history. And so you can actually track that 14 hours ago, I made this commit message with these changes that I'm tracking here. And 10 hours ago, I made these changes with this commit message that I'm tracking here. So the reason why you're doing all of that is the more information that you give to GitHub to track your changes, the more powerful GitHub is as a tool for you as a developer to be able to help you debug and go back in time through your code for both for you and when you're looking at your code, because projects have a way of growing larger and larger and larger and have a way of you can't hold it all in your own head at one time, but also for others with either within the team currently or those who are coming in to help on the project to be able to get a sense of where it's been. That's essentially what's going on there. But let's take a look at branching, because branching is a super powerful tool that GitHub provides, which allows you to again, really work on a specific area and clearly demarcate that you're working on this area specifically for this purpose, and not impact or have any sense of touching. You're not touching the actual core code, the main repository when you're branching. So branches are very easy and fast to create in Git. They're just a pointer to a commit, which is very different from the centralized version control, which will do a full fetch of all your files in a directory structure. So let's take a look at this example here. So here's the master, which is the master branch of your repository, which is the central clearinghouse of all your files. And then here's your Git commits, right, with their reference numbers. And here's a feature branch that you've created. So let's say you're working on a program, a web application. You want to work on creating a navigation bar for that web application. So you might want to check out a branch and name it navigation bar feature or nav bar simply. And when you are working on the nav bar feature in the nav bar branch, every time you commit to GitHub, every time you push up to GitHub when you're in that branch, you're actually pushing to that branch. You're pushing to this branch here. You're not pushing to the master branch, which lets you keep your code clean, right? So in your feature branch, you're probably going to break this program because you're going to make some changes while you're iterating on it that are going to be breaking changes, things that are going to make this not work in a production mode while you're working on this feature. And so if you're doing that simultaneously in the master branch, you run the risk of pushing changes up to something that's alive and working and out there and breaking it. And then you get all those frustrated users who can't access that wonderful program you've created because you've been working on a new feature that has now temporarily broken it. But if you check out a feature branch, you actually can make all the commits and push up to GitHub as much as you want without any fear of breaking the actual master repository because you're in this feature repository. And then when you're done, you can then merge the feature branch back into the master branch and commit all the changes you made into the master branch once you know that this feature branch is fully working. It's really awesome. Yeah, I think they do use pretty good version control. But you know what's a great example of that is, does anyone remember the Twitter whale from the earlier days of Twitter? When Twitter was rapidly expanding and you would try to use it too fast, right? Exactly. And you get that infamous Twitter whale. And even and there was something else on Amazon. I forgot what the thing was, but Amazon also has something that would show you, right? Long live the whale. So, you know, you don't want those things to happen. You want your program to work well. And checking out branches is a great way to work on a new feature that you know will be breaking your program temporarily while you're working on it without running the risk of having the whale come, you know, like from a Hitchhiker's Guide to the Galaxy, thanks for all the fish, right? Like having that whale come. So, so Git Branch will show you all the local branches on your computer. So if we would look here, there's only one branch here, right? We haven't checked out any branches in this repository. Although, I believe if I go to this one, I did do branches. Yes. Look at all these branches. There's a lot of branches. And so these are all different branches of people who were working on this project who checked out different branches to work on specific things. So this is a great example. So here's a branch that this person worked, who checked out 2 branches, one to fix mobile responsiveness from the About page, and one to fix a height image on mobile responsiveness on the About page. And he clearly, besides the typo, which we all make typos, right? He clearly labeled his feature branches so all the other developers working on this program know what he's doing, right? And here's a branch, fix up linting errors. Linting errors are essentially like, is your code structured in the right way? Is it spaced correctly? Is the tabs correct? So fix up linting errors. So someone went and checked out a branch to fix those and then merge them back into the master branch. So that's a great example, right? And here, Git Branch feature, change the name of feature for what you want to call it, will create a new branch called feature from the current branch latest commit. Get checkout feature will change the branch to feature, right? So if you wanted, so let's say I wanted to go to this branch. I would type git checkout fix uplinting errors, and I would move from this branch where I'm currently working on, the refactor API reducer branch, which I created, and I would go to fix uplinting errors branch, right? Skip that for a minute. You can also check out a specific commit by referencing its commit number. Pretty cool. And then merging is, so git merge feature. This command merges master into feature and will create a new merge commit. So let's just take a look at this example, see if we can figure it out. So here's the head. This is like the overarching, this is our repository. Here's the master branch. Here's all the commits that we made. This commit leads us to this commit, which is on the feature branch. We go back up, right? Or, well, somewhere like that, and we can merge back in. And this, well, that's a great example, actually. So we're on the feature branch. We make a commit. We make another commit. We merge it back up here. And what line is this on? This whole line is within the master branch, right? So now we put ourselves back into the master branch. We're not going to worry about rebase for now. That's a great topic, but a little out of the scope for our time together. And git reset on undoing things we'll work on a little bit later as well. So let's take some time. And by the way, if you wanted to go through all these things, once again, great website. This is a great blog post. Fantastic blog post. Highly recommend it. So let's do this. Let's have fun. Let's create a new directory called Flatiron Study Group. Let's cd into Flatiron Study Group. Is there anything in there right now? No. Let me just close Adam here. There's nothing in the Flatiron Study Group, right? Because all we've done so far is we've made the directory and we've changed into it. We haven't done anything. So let's make something in this directory. Actually, before we even do that, what is that going to do? Get an init. That's going to initialize this directory as a new Git repository. Let's enter. Initialize empty Git repository in this file branch, right? And then let's create a README. So now within our repository, we have, which is now a Git repository, we have a readme.md. Cool. Let's play with it. So what do we want to do? So let's open our README. And let's say, I see a chat. Let me just take a peek. Great, fantastic question. The question is, so anyone can clone a repo and then push to it. And does that create a pull request for the owner of the repo to use the changes, or does it have the privilege to change the master? That is fantastic. Fantastic question. Let's take a second to review that question. So let's go back here. Let's go to this project. This is a project I was happily working on. Is today Monday? Yes. I was working on yesterday at a hackathon. So this project, look what it says here, forked from this repository, right? So the master repository for this project is there, right? And I can click on that, and I'm back in that master repository. 264 commits, 13 branches, 6 pull requests. We'll get to the pull requests in a second. This is me. This is my local copy of this repository right here. It is not this. It is this. So when I create a commit in this on my computer, so when I go into my local directory of that file, of that repository, and create a commit, and I push it up to GitHub, I'm not pushing it to here. I'm pushing it to here. Does that make sense? It's not going here. Now, how does it get from here to there? Because presumably the reason why I forked it and then cloned it and then worked on it was because I wanted to make some changes. I wanted to push up some new code to the actual thing. So how might I do that? You can actually do that in this beautiful GitHub user interface here. Beautiful GitHub user interface. You can do that by going here to the master repository, clicking, well, first of all, let's take a look here. These are the open pull requests within this project, right? Here's the one I created yesterday. This is what it looks like. So a day ago, I created a pull request describing what I did. When you create a pull request, you want to make the language as clear as possible for the maintainer or maintainers of the GitHub repository so that they understand exactly what you're doing. Yeah, that's right. A pull request is like a polite request to ask to modify the master. Is that correct? Exactly right. It's a polite request. So just going through this for a second. So describes what I did. It embodies, encapsulates the commits I made under that message are all here, right? And then I worked on a separate issue. And then the maintainer of this repository, which is this person here, requested changes, which is a feature that you can do as part of the back and forth of a pull request. I, as the contributor, submitted a request to add some changes. The maintainer can either reject them, can request changes, can comment, can merge them into the repository, has all sorts of features that that person can do. So she responds saying, it would be great if you could do a couple more things here on this. She looks through my code, and look at this. Red means these are the things I deleted. Green, and GitHub does this automatically when you're looking at modifications. Red is deletions, green is additions. Nice, great. And then I mentioned I'll work on this today. Very cool. I worked on it, and look, there is my commit message for it. And there was something else I couldn't figure out in that moment. I figured it out shortly after. An hour later, I added a new commit, changes requested. So, and that's where it stands right now. Pretty cool, right? And with any open source project, there's usually contributor guidelines for how to work on the project. Like in the month of October, DigitalOcean and GitHub run a wonderful project called Hacktoberfest, where anyone who is new to contributing to GitHub open source projects, you can actually, look at this, 31,000 challenges, 239,000 pull requests were opened in the month of October, this past October. And if you did a certain amount of them, you actually got a t-shirt, which is kind of cool. And a great way to get developers to do free things for you by offering t-shirts. There were 64,000 repositories that participated in this challenge this month, in that month of October. And then there were all these projects. You could go and look at them, and people tagged their projects with a label of Hacktoberfest, so you can 15,000 issues you could have picked to work on. Pretty cool. So you can really search through GitHub. And a great way to start if you're looking to contribute to open source code is look at the gems, the Ruby gems, or the other libraries that you use a lot in your own projects and say, I really use this a lot. I want to go from being a consumer of it to a contributor. Let me go look at the repository of that library or that gem and see if they have open issues. See if they have some contributor guidelines, and let me get involved. Great question. So here we are. We are editing our README file, right? Flatiron study group, Git Repository basics. We got this. Cool. Let's go back into that directory. What do we call it again? Flatiron static. Let's type git status. What do we see? We have one untracked file, readme. So we can either do git add readme.md, or just as short, unless we have a reason not to, we can just put the dot and it'll automatically add it. Git commit m added a readme and put in title and subtitle. That sounds good, right? Look at that. So master, this is the reference number. Add a readme and put in title and subtitle. 1 file change, 3 insertions. And this is the track create mode readme, right? So now git push origin master. Oh, interesting. So let's actually take a look here for a second. That's a good point. Let's take a look at my repositories. Does this repository we just created exist on my GitHub on github.com? It's not there, right? So how do we get it there? Pretty good question. Look at that. So what I did here is I created a new repository. Instead of doing it from the terminal, I did it from, again, the handy dandy interface on GitHub. And here it gave me some really cool tools. So if this was a brand new repository that I had not created here, it gave me how to do it, how to initialize it on my own computer, which looks very similar to what we just did, right? Git init, git add, git commit, git remote. This is the one thing we didn't do yet. Or push an existing repository from the command line. So we have an existing repository down here, right? What we want to do is we want to push it up to our GitHub up here. So all we need is to add the origin, because what was the error here? Origin does not appear to be a Git repository. We don't have an origin. We don't have a place remote for us to define. We haven't defined it yet. So I can just copy and paste that. And there's the link, right? That's in there. And now, if I try pushing, counting objects 3, compressing objects, writing objects 2, the master, right? And it's from the master branch to the master branch. And now, if I go and click on code, look at that. We have a repository, and we have one commit. Added readme and put in title and subtitle. Latest commit 18F4B47. That's the reference number 3 minutes ago. One commit. There it is. Pretty cool, right? Now, if we look at, let's see, what do we want to see? So, Git Branch. We did Git Branch. What do we want to call it? Feature. Now we have 2 branches here. Pretty cool. Git branch checkout feature. Now Git branch. Oh, sorry, I just actually created a branch called checkout. That's not what I wanted to do. Let's let's take a look here again to make sure we do it the right way. Where were we? There we go. So how do we check out that branch? Should be, oh, because I typed git, what was the command? Git checkout feature, let's see. Because I typed branch there, that was my mistake. Switch to branch feature. So now if I type git branch, well, we have 3 branches, one I created by mistake. But now we have 3 branches, and we're checked out on feature, right? So now let's go back into our README. Adding this in the feature branch.
Can I ask a quick question, Ben?
Of course you can.
When you were back there and the feature branch is green, does that mean that is the branch that we're in at that time?
Right. It's giving us a handy color coding reference to which branch we're currently living in right now.
So we're not messing around in the wrong branch? That's
We're
awesome.
not messing around in the master branch. We are messing around in the feature branch. So now git add, git commit, added a sentence to readme, git push origin master. Right. That doesn't work, right? Why would that work? Does anyone know? What's wrong there? Why is it saying everything is up to date? We just made it.
I think it's because you have to be in the. Don't you have to be in the master branch to do that?
Yes. Perfect. What did I type? Git push origin, pushing to the origin from the master. But have I made a change in the master? No. Git push origin feature. So now let's take a look at our repository. 2 branches. Your recently pushed branches feature less than a minute ago. 2 branches feature updated a minute ago. Pretty cool. And pull requests are not only from one forked copy of a code to the other forked copy, let's say from your clone down copy to the main repository. You can actually make a pull request, and perhaps the most common usage of pull requests are when a bunch of developers are all working on the same code and they're making pull requests within the same code, and to allow themselves to be checked by their colleagues and to create some tracking of the changes they're trying to create. So we can actually compare and pull requests. So we can compare. Look at this. What is the change? This is what it looked like before. This is what it looked like now. And you see the green because we adding this in the feature branch. So we can create a pull request by saying added a sentence to readme. Working on the readme file by adding a sentence at a time. Create a pull request. Now we've created a pull request. We can click merge pull request, confirm merge. Pull request is successfully merged and closed. We can now delete the branch. And if we go back, we have 1 branch again, and our readme in our master branch has the thing we put in. Any last questions? Unfortunately, our time is coming to a close. But any last questions on this? I see the chat box. I'm going to it quickly. Say if I lost all my data, can I just go to the repo, clone, and still confirm where I left at? Yes, you can do exactly that. And that's why it's so important to make sure you push up as often as possible so that the repository in GitHub is as up-to-date as possible. Should we push after every commit, or does it make sense to do it after several commits? Different philosophies on that. Amanda, one philosophy is to do it after every commit. One is to do it after some major change. Probably the truth lies somewhere in the middle. Anytime you're making anything substantial or doing something that is really making a change, probably makes sense to push it up for the reason that was just articulated before in the question, that if you lost all your data, you want to get the most up-to-date repo that you can. So the more you push up, the better you're going to be in doing that. Any other last questions? Thank you guys